Hello, I'm Kacel and I would like to present you my paper, Occupant and Environment-Related Parameters in the Evaluation of Visual Environment and Experimental Design. Firstly, I will give a brief introduction and the literature review about my paper, and then I will tell about the experimental study and its results. I will conclude. Investigating parameters related to occupant and environment can provide important information in POE and IEQ studies. Adaptive behavior has been widely studied in thermal comfort examinations, but literature indicates some effects of adaptive behavior on visual comfort. So this research aims to evaluate adaptive behavior parameters in relation to lighting, and the research methodologies has been an experimental study. This study has been significant because it proposes to integrate the assessment of occupant and environment-related parameters into POE procedure for a holistic evaluation. As the literature review, Photios has indicated, based on the previous work of Akashi and Boyce, a decrease in illuminance levels with a higher correlated color temperature and with a higher color render index. Weich and colleagues investigated the relationship between user, workplace, and lighting parameters. For example, they indicated that lighting appraisal had impact on room appearance and appearance affected pleasure, or lighting appraisal and room appearance had impact on workplace satisfaction. As adaptive behavior options, K. Vanfar and colleagues and O'Brien and Gunay indicated some parameters such as use of wallpaper, blind control, task lighting, changing the desktop or touch surface, changing furniture position or direction, changing the occupant position or orientation, or monitor orientation. So the experimental study has been carried out in a full-scale test room with an office function in lighting laboratory with no daylight. The experiment has been carried out as between group tests and within subject tests. In the between group tests, environment-related parameters were investigated as the independent variables. These were lighting system parameters and interior design parameters. As the lighting system parameter, CCT and illuminance levels were investigated as a combination. So low-level CCT with a high-level illuminance level and high-level CCT with a low-level illuminance level. As the interior design parameter, wall color was investigated as beige and blue. And in the within subjects test, occupant-related parameter was field of view. So 2 different occupant positions and 3 different occupant orientations were analyzed. In the dependent variables, starting from the lighting appraisal, going down to self-assessed productivity, was taken from the study of Weich and colleagues, and the first 4 parameters has been added in the frame of this study. In the experimental study, 4 null hypotheses was tested. So these hypotheses were mainly based on how the evaluations of dependent variables change when we change the lighting parameters and interior design parameter. So illuminance level, CCT, and wall color. As the instrument, an occupant survey was carried out through a questionnaire, and illuminance measurements were done on the horizontal and vertical surfaces. In the experiments, there were 36 participants. They were students at Istanbul Kültür University Ataköy campus, where the lighting laboratory was located. In the bivariate correlations, it was possible to see how the dependent variables correlated with each other. So, for example, one of the most significant correlations was between furniture position orientation and field of view. Or, for example, color of internal surfaces correlated with pleasure, environmental satisfaction, and self-assessed productivity significantly. The null hypothesis was tested through ANOVA tests. For example, in the second one, for the blue wall color, the means of all dependent variables decreased from case 1 to case 2. And also, there were statistically significant differences between case 1 and case 2 for 5 dependent variables: lighting system, lighting appraisal, room appearance, environmental satisfaction, and self-assessed productivity. It is possible to reject this null hypothesis for these 5 variables, and it can be said that the evaluation of these 5 variables was different between case 1 and case 2 for the blue wall color. In the within subject experiments, the means of same questions was compared between group tests and within subject tests. And also, when the occupants changed their positions and orientations in the within subject test, their field of views changed. So the illuminance levels in their field of view, so in other words, the surfaces that they were facing at, have been compared between group tests and within subject tests. So whether they decrease, the illuminance levels were decrease, increase, or remain the same. So the means of all dependent variables decreased from case 1 to case 2 for the blue wall color. For case 1, the means of all dependent variables increased from beige to blue wall color. In the within subject test, the means of these variables that you see improved most, but the means of lighting system both remained same or decreased most among the participants. And the participants who had a lower or higher average illuminance level in the field of view evaluated the dependent variables with higher, same, or lower ratings. So in order to conclude, it's possible to say that there's diversity in occupant acceptance, and occupant assessments and environmental related parameters are significant. A holistic evaluation can be achieved through integrating adaptive behavior parameters into the evaluation of visual environment. Thank you for listening.